Yeah, it's not on. You advance it? So how the series we're doing is, so tonight I'm going to kind of lay the groundwork for have a more of a thorough discussion about climate change in general. The next session I'm going to get more specific to our region of the world, some of the pros and cons of what's going to happen with climate change. For Indiana, it's not all bad. Climate change, you want to know the truth. So it's for at least in my age group, it's not going to be that big of a deal. And then on Tuesday, we're going to go through some impacts of local and national produce and crop production. And we're going to talk about what we can do, in the last session. We'll talk a little bit about what we can do in landscaping and crops too in the second session. So I'm going to get more specific as we go through on things we can do and what's happening locally. So in weather, we're just observing what's happening currently. So when we talk about weather, it's what's forecast in the short term, not the long term. Where climate change is, we're looking at 30-year periods where we're doing climate collection and looking what the weather has been in a region. Then they will adjust the norms of what weather is. Our norms were just adjusted this year, so it just happened. So for weather predictions, we have a lot of tools that when we had tornadoes, when was that? Was it Easter when we had those tornadoes back in 1968 in Napa?
1965.
1965?
No, they had separate ones.
I think it's 68 in Napa.
No,
But we didn't have
they had,
Palm Sunday tornadoes, wasn't that what it
it was
was?
1965.
Okay, 1965.
But Napa was hit a couple of years ago, wasn't it?
Yeah.
The last 10 years.
Yeah, but they were in the Napa region back in 65. Too. That's a big deal. But we didn't have all these tools to predict the weather. So Doppler radar is giving a lot of detailed information available to our national weather forecasters, 159 towers across the nation. So we have a lot of data collected just by Doppler radar. We have satellites in the air collecting data, which we didn't have back in 1965. So again, we have a tool that hasn't been around that long that's giving a lot of detailed data, radio sondes. These are devices that they just float up in the air with balloons to collect atmosphere data. So they have tools they release that float around that collect data right from the upper levels of our atmosphere, which helps with monitoring weather and forecasting. So they're asking to put one of these stations in Marshall County, because we have a hole in the state of Indiana. But it's a ground level weather automated collection devices, getting wind speeds, barometer readings, soil temperature, rainfall data. So they have a lot of data collection at these sites. And we're kind of
Have they picked on an area for it yet?
that's why I got involved. I'm thinking I want it to set someplace where it's going to be monitored and protected. So they thought fairgrounds, our fairgrounds isn't. So I'm going to suggest either at Co-Alliance where it's a fenced in area or at the jail. I don't think people are going to go mess with the weather station by a jail.
I was going to suggest a college myself, but that's all right.
And still a college? Well, that's another good choice, but I need to contact them because it needs to be a site that people aren't going to wander and bother the equipment. Yeah, so we need.
College kids would never do that.
No, they wouldn't do that.
Where'd you say the other area was?
Do what?
Where'd you say the first area was?
Well, Co-Alliance, I'm thinking they have a lot of stuff they need to protect, so it's in a fenced-in area.
What's it?
Just north of Argus.
We'd be able to access that from a phone app or something. Personally?
No.
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 This will all be just strictly
a collection point for meteorologists, and then the data will be shared immediately. Because it collects data 12 times, several times throughout the day,
Okay,
how often they want it, but routinely 12
so
times.
basically we'd have to access that information through NOAA.
Correct.
Okay.
And, but that's why we're putting one here to collect the data locally. There's other sources of information for data, which Christina's going to talk about one of those tonight. So then we have NOAA's weather and climate operations supercomputer that's crunching all the numbers it's receiving to predict weather systems as they're coming across to give us forecasts. And then with the advanced weather information processing system, which further utilizes data to make predictions for weather alerts so that we receive alerts timely as needed. Though, you know, what's amazing is we still get straight line winds or tornadoes. They don't even know what's happening. They can say there's a cell here, what's going to happen. And I know for a fact that we had, my daughter saw a tornado that they denied and it wiped out some farm buildings close to a house we lived at in southern Indiana. And no one ever agreed that that event happened other than the damage to the building that did occur. They documented something happened. So we still have to be cautious. And what's amazing is when we're doing our long-term weather predictions, they're utilizing meteorologists 9 different models. So that's why there's a percent of whether it's going to be abnormally wet or abnormally dry, or if it's going to be excessive heat, less heat. And whenever you see long-term forecasts that's white, that means none of the models agree enough for them to predict anything. So it's not that all the 9 models are in unison. They're using these 9 different models to try and predict based upon a percentage of the ones that are agreeing. So there's not much agreement. There may be equal chance or just a low percentage of something happening in the future. And that's why a lot of times we're wrong, because even though we have a lot of data to look at, it's hard to predict what's really going to happen.
Constantly changing. It's constantly changing. Yeah.
Yeah, so
So
we have,
how to stay ahead of that? How do you stay ahead of that?
it's really hard because there's a lot of things that factor into weather.
Sure.
And that's why I know Mike Hoffman was at a meeting once and he was saying he wanted to do 14-day forecasts. He says, there's no way. I do it because they tell me to. That's not that I think it's accurate. You know, when you get that far out, you're on the verge of just guessing a little bit. You're trying to find a trend in information from these models and information that's collecting to utilizing these models to try and make a prediction based upon the information you have, but it's never, and we know that. We have that joke, don't we? What other job can you have that you're 70% wrong, but you get a raise?
I always said it. I'd love to be a meteorologist in Arizona. You can take the day off because it's always the same. Mostly sunny, you know, that's it. You take the day off, have it, just let it go. So that's a great. You know, the average meteorologist makes $90,000 a year because everybody watches the news for the weather.
Yeah.
Right, then, because you only make 34,000.
Yeah.
That's why fundraising might quit.
National Geographic said years ago, the best they can do is 3 days.
Yeah, that's what Mike said.
Yeah.
He said he agrees with that. That's what he was saying at my meeting. He says 3 days out, you have some idea of what's going to happen,
Right.
but you aren't precise on that 3rd day yet. But you have a better ability to predict what's going to happen. So that's why when we're looking at these long-term, this is just a 30-day forecast map, utilizing those 9 models to predict it. And you can see there's a lot of areas with equal chance because the models are not in agreement of what's happening in those areas. So it's they're not bold enough to predict. And the lighter colors is more of a trend among the models indicating that that's going to happen. So they're not very sure that that's even going to be that accurate. I think our state climatologist, I mean, we were like hunkering down to have a drought this year, and look what happened early on. I mean, and she even had a drought meeting set up to help, so to be on top of it, how we would react to a drought. And our drought went away. We were abnormally dry for a while in northern Indiana. So when you get up to the darker colors, that's a much higher probability that it's going to be abnormally dry up in there, unfortunately, because that's North Dakota. And South Dakota, they're finding surprises now in the crop report. They're getting better yields than they anticipated, but North Dakota was just totally devastated this year. The center part of it, they plant spring wheat to harvest and utilize spring moisture to grow that crop. Since they don't know what's going to happen later in this year, they didn't have anything to harvest. So in a central part of North Dakota, that abnormally dry is continuing a pattern that's been happening this year. So that's
The left one's temperature, right? And the right one's precipitation.
right. So over here is a high probability of above average moisture. So that's good for us. So we're going to keep for the next 30 days having moisture in the most critical time of the year for growing crops and lawns, August, when it's the heart of the summer. But we're not going to have that much heat, so we're going to have more normal heat. So that's good news for us. But then again, where the drought is, they're going to have below normal moisture and above normal temperatures. In fact, it's over 100 degrees up there today. So good place not to visit. And you would think moving from Indiana up to North Dakota this time of year would be the right thing to do. Not today. So how does weather really happen? It all starts with solar radiation. This is where weather comes from. And also the ability of our Earth to exist with life, biological life. So actually 30% of the solar radiation that reaches the atmosphere is reflected back into the space. So it never gets to the surface. 2/3 of that reflection is due to clouds and small particulate matter in the atmosphere called aerosols. So that is reflected. And then another factor, in addition to aerosols and the clouds is the lightness of the soil. So where there's, no wonder we never warm up the winter. The snow helps reflect the solar radiation back up into the atmosphere. The deserts does as well. So areas that are light colored on the earth. So vegetation does matter on climate. So that has an impact. What can impact it? Can we go back? Is things like volcanic eruptions that increase the aerosols or particulate matter in the atmosphere will keep us cooler. So all those fires happening out west, as that smoke filters over this way, that's creating a barrier that's going to reflect more of the solar radiation back to Earth. So events like that can have an impact on temperature. In fact, that one fire was creating its own weather pattern around it because it's burning so hot. So that was interesting.
Doesn't do much for solar panels either. Particulate matter in the air.
Right. I mean,
Because I've got mine on my garage in the last couple of months have been down year over year.
well, it doesn't do much for crop production because that's limiting the amount of solar radiation that's reaching the crops, and crops are inefficient in utilizing that solar radiation to begin with. And when we get less, and this is just me. If you look at the number of sunny days in Plymouth, Indiana, I wonder why anyone moves here. Because we got overcast is over 60% of our days. Not necessarily rainy weather, but overcast conditions is common in our area, which is good because we have moisture. I get sun in Arizona, but I may not have any water.
No, that's right. It was pretty good in the Midwest.
So 70% of this solar radiation does hit the Earth's surface and is absorbed by the Earth's surface. To balance the Earth temperatures, the Earth is releasing, re-radiating that energy back up into the atmosphere. So if it didn't, we'd just burn up. If the Earth really absorbed all the energy, it was reaching it, and didn't release it back up, we'd be in trouble. It'd be way too hot. We wouldn't even have to worry about greenhouse gases if that was true, but it's not. So everything's emitting this long wave radiation back up into the atmosphere on Earth. So Earth temperature would average -2 degrees. That'd be our average surface temperature on Earth if we didn't have greenhouse gases. So that would be more of our ambient temperature. So there wouldn't be biological life on this Earth. It would be more like the moon than the Earth is today. So my question is, we'll get to that. Yeah, right now. So why is the Earth temperature around 57 degrees Fahrenheit? That's why we can use geothermal, because in the summertime, that 57 in our soil will actually cool things as we pull it into our house. So it's not as expensive to cool our house. And then in the wintertime, it's not as expensive to heat our house because the soil temperature is around 57 degrees. So as we pull in that air through that geothermal system, it's a lot less expensive to heat our houses in the wintertime. So that's a nice advantage. So why is that true? If radiating all the radiation energy from the Earth as it to dissipate it back up into the atmosphere would put us down at -2 degrees Fahrenheit, what is keeping us at 57? I need a guess.
The oceans?
Oceans, that's a good point, because here in northern Indiana, we can grow peach tree crops efficiently by the Great Lakes because it holds that energy in the winter time, and it keeps everything at a more of a even temperature during the winter. So it's actually a zone 6, where here in Marshall County we're zone 5, and we are able to grow peach crops up there consistently each year because we don't have that up and down warming and cooling in the spring either. So it's more of an even transition from winter into summer months. So they don't get the severe cold because peach trees are actually a zone 6 plant, zone 5. And then they don't have that damage to the flower buds because as it warms up there, it tends to stay warm, and you don't have that really cold event because usually I always say you get one good peach crop every 4 years and a decent one every another year. But we usually have what happened a year ago is it warms up, the plant comes alive, and late into the spring, it gets a cold event that kills stuff. So water does help manage temperatures.
I was just going by the fact that 80% of the Earth is water, so obviously it has a major effect on temperature.
It does. It does. And that's, we'll get to discussing that here in a minute, but it does. Okay, let's see what my answer is. Greenhouse gases. So we have greenhouse gases and clouds that act as an insulating blanket over the Earth's atmosphere. It doesn't trap heat, it lets it emit slower. So it still is emitting it, because if it were truly trapped it in, we'd be burned up too. So that would, it's got to release it, but it releases that, it slows its release into the outer atmosphere, away from our Earth, so that we have a 60-degree plus average temperature on our soils. So my question was, are greenhouses good or bad? We'd all be dead without them. So I guess they have a benefit effect, but what's happening currently, we'll get to that, is a concern. So that is why we have an average soil surface temperature of 57 degrees, is because of that solar blanket. So clouds tend to have a cooling effect on the surface temperature due to it has so it can help be a blanket, but the real thing it does is it reflects the solar radiation. So the clouds on the why the sun is out is actually keeping us cooler instead of keeping us warmer, because it's reflecting the solar radiation back into the outer atmosphere. But when we know that it can have that warming effect is when the sun goes down and it's not reflecting solar radiation, it's just holding in that warm temperature. So in the evenings, we all know this, on a clear night, it cools off quicker than on a cloudy night, because then we get to feel the effect of it holding in the temperatures to allow us to enjoy a warmer evening. On that, and also that would be protecting my, okay, I'm an agriculture guy. So like our cherry trees, you ever see a cherry tree that's been split on the side of the tree? That's on a cool night where the clouds are not there. And it goes from being a warm, sunny winter day to a very cold day quickly. And the cambium layer of the tree can't adjust to it fast enough. So that's what creates that crack. So if it'd be a cloudy night, that hold in the temperature and that cracking wouldn't occur. And that's why on some trees that are thin bark, because it being young, or the cultivar, sometimes we protect them from heating during the summer, winter days, so that cracking won't occur. So that's just an impact of how solar radiation is held in by our soil surface. So on a clear night, it dissipates rapidly, even though it's a warm day. On a cloudy night, the warmth will linger on. So in the winter times, I enjoy the clouds for sure at night. So what is greenhouse gases? So when we're looking at a couple things about greenhouse gases, carbon dioxide is an interesting greenhouse gas. It's the majority of our greenhouse gas. It has the least amount of global warming potential of all the greenhouse gases we talk about. But the life of the gas is 100 years plus, and that's kind of an average. Some can stay up there for 1,000 years, carbon dioxide and our greenhouse gases. And so we could have carbon dioxide up there from George Washington when he was a little boy lighting a fire that went up into the atmosphere, potentially. Most of it, though, cycles back into our oceans and into our landscapes. Actually, most of it goes into the oceans. There's a big carbon cycle in our oceans. So that's why it's 100 years plus, because some of it's not even close to 100 years, because it goes back into the carbon cycle quicker than that. And then some of it will get in the upper atmosphere and stay there a really long time. So that's why that one's kind of variable. So I messed up on this bottom one. I just saw that when we get down there. So methane is 9 to 12 years. We talk a lot about it because it has a global warming percent of 25 versus 1. Nitrous oxide has a global warming potential of 114. And it makes up 7% of our greenhouse gases, and its life is over 100 years. I'll correct that from that. I can't believe I did that. And then I got focused on the fluorinated gases that make up 3% of our greenhouse gases because of their global warming impact, and that should be 50,000. And the percent is 3, but its life is 3,200 years for the sulfur hexafluoride and 7,390 years for this PFC-14. It's a carbon and fluorides that make up that molecule. So once it gets up there, it's up there forever, 7,390 years. 3,200 years. This one's like 100, nitrous oxide is 140 years. So those are lower percents, but they're hanging up there once they get up there for a long period of time. So that's good from a global warming standpoint to maintain that blanket. And their percentages aren't changing as much as what carbon dioxide.
What's the typical uses for nitrous and the CO6 and CO4?
Nitrous oxide is a type of ammonia type product, a nitrogen product. So it's more connected to, as is methane. Agriculture could be a source of it. Bogs where things are decomposing and releasing various forms of nitrogen back up out of it. And other industries are releasing these nitrogen type products that'll go on up into the atmosphere.
Is Bob the significant contributor?
It can be. For example, when I have a saturated soil, nitrogen is released up into the air. You know, so if I'm a farmer and apply nitrogen to my soils and it's saturated and it's warm, the microorganisms steal the oxygen off of the nitrates in the soil and release nitrogen into the air. But that's not bad because nitrogen is already in our air. We have a lot of nitrogen in our air, but the nitrous oxide is one that will be a greenhouse gas, and that's coming out of different agricultural waste sources and the environment. Part of this is actual just natural cycling of nutrients that we have.
As well as industry.
And industry is a source too. So, so there's a lot of sources, and I'm going to talk a little bit about, at least from a carbon standpoint, that a little bit more about carbon cycling, because if we're reusing it in our various ways, we can help reduce the carbon dioxide in the air. You know, so some of the issue is the carbon dioxide is being utilized to provide, you know, it's being utilized when we're heating, using air conditioners and things like that, but there's no carbon cycle. It's just going up there, and our carbon cycle is overwhelmed. It's not retaking it back in because we're releasing carbon that's been stored that wasn't part of our carbon cycle anymore.
And then the CO6 and CO4, what's the main contributors to that?
Well, it's industry, different industrial components, making aluminum even will release some of these. So it's different industries that are contributing to the release of that. So we have to be careful.
Would that include air conditioning and that sort of thing, or is that a different type of?
That's impacting our ozone layer, so we don't want to be releasing those. But yeah, it could be part of it too.
I can't remember, you know, they made a recent switch to a different type of fluorinated gas.
They're actually looking at technology for air conditioning that's going to be based upon evaporation more so than artificially being forced with these compounds that we're currently using. So China, do what?
That works well in dry climate.
It works well here. That's how we cool our livestock now. We use water systems that we reduce the temperature. And actually, there's a city in Europe, in Germany, that in addition to one of their large cities, they put in bio landscaping. You know, instead of having all the rainwater go in tubes and pumping it away, they're having soils to absorb it and have plant growth, and they have plants on the top of the roofs. And they're trying to create a different environment in the cities instead of just concrete, to try and balance out the, you know, the weather conditions. So it's just naturally cooler. So we don't need to use as much air conditioning. So it's those kind of systems that in Europe is ahead of us in some examples, but that's one that they did. And guess where they made the mistake? You know, a major rain event. they didn't have, so it flooded, so you gotta be smart enough to realize you can have rain events where it's gonna be more than can be absorbed in the soil. Those of us that farm know that already. So you still need a pipe underneath there to collect excess water when those events happen. So that's the only mistake I could see that they're doing, but they're just incorporating more green spaces in among all those concrete jungles. Instead of having concrete jungles, you have parks and stuff. And that means maybe you're going to not be able to build the buildings side by side anymore, but then you're going to have a better environment. And maybe break up these wind tunnels too. I mean, how many of you walk in Chicago and thought you're going to be blown away? So maybe we can do better city engineering that's climate friendly and help alleviate some of the issues associated with the needs to cool it.
Waste management is working on it. You've seen the trucks. The trucks will run by their own garbage. They burn the garbage that they pick up and fuel the trucks. That's a great idea. Now that's an early concept. I'm not sure if it's actually.
There's a city in Eastern Europe that's down to 4% of the trash ends up in the landfill because they're utilizing some of their trash to do that heat generation,
Yeah.
like a methane digester to help supply the heat for the city. There's others that they're just turning back into soil. So, they on their streets, they have a bin and you have to have a card to get in your bins because they don't want people dumping the wrong things in there. So you have a card that if you have bio waste, you go here, and then they're starting to have places where instead of, how many times you have to, you buy a new plastic jug to hold shampoo. So they're having them reuse them and go buy and get this out of a dispenser versus getting a new shampoo jug every time. So they're doing things so they have made a major change in
Repurposing, sure.
Yeah, so that it's already been done in Eastern Europe, their major city, and I forget what country, but so I mean Western Europe. I'm saying wrong. Western Europe. So it's one of those countries that used to be part of the Soviet Union complex, but they're being very proactive in how they're managing the waste in this city. So they went from, you just throw how much stuff do we throw away that could be recycled?
Too much. China stopped. They used to buy our garbage. They're not doing that anymore. So we've got to figure out what do we do with our
Recycling
garbage.
plastics, no one's using it.
Yeah.
But so this country had a side solution is maybe we can use less plastic. So that was our goal, was to think through systems where you use less of stuff. When I was young, you went into a hardware store and you bought a doorknob. Yeah. I don't know if anybody can remember that, but it wasn't in a package. It was in a bin.
Yeah.
You went to a bin and you bought the doorknob. All you bought was a doorknob. You didn't buy all this plastic.
All the everything in clamshells. Yeah.
Yeah. So, so there's ways that we could go back and turn that back. And we're going to need to do that because everything we do to reduce greenhouse gas production and pollution per person, it's good. The real issue is our population is growing. So I didn't put this in here, but it's going down per capita, but still going up globally because we keep having more people.
Could you use the methane that you would use for heat? Could you use that and then recycle in the greenhouses in January and February here and actually utilize your greenhouses that time of year and do it that way?
Homestead Dairy, Jill Boone was thinking about doing that, having a greenhouse business, utilizing their own energy to heat the greenhouse because that's so costly to heat a greenhouse. Chicago, they have greenhouses on top of the building because we all know hot air rises. So they just capture that hot air coming from the building. They're growing local greens and stuff to use local. So there's ways that we can utilize that stuff. And then all those plants growing on top of that building in Chicago is also cycling carbon. That's going back out into the community. So there's things that we can do. It's just that we have grown up in the United States where we have this waste mentality because there used to be always another acre, another property we could go to. So we haven't matured like Europe has. That's been had to focus on land use quicker than what we did. So they do things differently than what we do. You know, we don't have we have this urban sprawl across our countryside. They've got their populations, I don't know if it's good or bad, but where they can service them and collect stuff more conveniently, and they maintain their agriculture areas more agriculture, so they can be productive and grow trees and stuff. So this is what's really exciting. So we've got, you know, we got all this solar radiation coming down. A significant percent gets absorbed by the soil surface. But I didn't talk about this, but a significant percent gets absorbed by the atmosphere and doesn't get to the soil surface. And then we have a significant percent that's getting radiated back up to the, you know, so this is the lighter colored areas that's going to radiate back up. We have the clouds that it's going to radiate it back up as well. And then we have the particulate matter up in the atmosphere that's radiating it back up instead of letting it get to the earth. So you can just see how we're getting these thermals. Has anyone flown a plane or been in a plane and felt a thermal giving you some bounce, some issues, you know? So that's happening as well, you know? So a lot of things are happening just by solar radiation, some of it hitting the earth and radiating back up, some of it not hitting our earth. And so the greenhouse gases over here is what's trying to slow it down, you know, so that's holding it in longer. But all is going to dissipate eventually. Or we'd be worried about what we're worried about, you know, a warming trend on our globe. It would happen rapidly if it didn't escape from the greenhouse gases. So that the purpose of the greenhouse gases is to slow it down. So more solar radiation arrives at the equator just by how the light is hitting our Earth. That's more of a direct hit, always on the equator. That's why they have more consistent temperatures. You know, and if you live around the equator, you pick your temperature by elevation. Not, you know, so if you want it to be 70 degrees all the time, you go up higher in a mountain area, like in Colombia. If you like 90-degree weather, then you go down lower. So it's a different way to live. So then the equator, it's even, but the poles tend to stay cold due to the angle that's at not an efficient angle to transmit that solar radiation to that surface. So that's why our poles tend to stay cold. That's why we have polar ice caps.
Is that supposed to be the sun? Instead of Earth rotates around the Earth.
No, it's supposed to be sun. Did I do that?
How much Earth's equator?
I think,
Where's that?
is it the change of like how the earth tilts? That's how I read it.
The same effect
The
is
Earth
felt
Kind of, it doesn't rotate, but I guess it tilts on axis, and that's why we have seasons. So
around the
as it
sun.
turns-
You're right, Marion. That's supposed to be sun. I didn't proofread enough. So that's what creates seasons, you know, because as our Earth rotates around the sun, it changes how the sun is hitting, you know, the Earth. We get day and night just because the Earth rotates, but rotating around the sun is what gives us seasons. So that, you know, in the wintertime, if you want to have a greenhouse that you don't need to heat, you have to build it to hit that lower angle sun to hit the greenhouse gas, so it actually heats the greenhouse more efficiently. So you have glass more at that angle to catch more of the sun. So if I want a greenhouse that works better in the wintertime, I build it differently so I can hit that lower angle of sun that hits our landscape at that season.
So, is that one of the reasons why they're concerned about the disruption in the Gulf Stream? The warmer surface temperature move to higher latitudes to the ocean current.
Correct. Yeah, our weather is really created by this whole issue of the sun warming the equator more than other parts of the earth being a globe. Because that heat, that energy wants to dissipate to those lower, cooler regions. So that creates currents in the ocean, the atmosphere, and some of our major weather systems. Actually, it's because it's trying to push that warmer air north. So our weather is, the solar radiation is really creating much of our weather. Now it's complicated by other things happening with these currents movement. But you're right. I mean, that's so that heat is creating new currents.
Will you be, for the next few sessions, are you going to be talking about the possible disruptions in Indiana regarding or related to the disruption in the Gulf Stream and that cold northern Atlantic front?
Well, part of the issue in the Gulf is the hypoxic zone. So that's creating a dead zone. So you're changing the vegetation in the Gulf because things aren't as actively growing in that area as opposed to the rest of the Gulf. So that would have an impact on the environment for sure. And yeah, I can talk more about that on another night. I'll give you some detailed information on it. We can incorporate that because I've got my coworker that's got a mind that remembers all this.
That's enough.
So, so this is kind of the issue that we're having is that we're warmer more in the center part of the globe, and then we have these polar areas that are cooler, and that's going to, we'll talk about how that's going to impact currents and issues here next. So we have atmospheric currents that are driven by the latent heat that we saw in that first slide about weather events, what's happening with solar radiation. So that's creating the atmospheric currents. Those currents create the ocean currents by wind on the water surface, evaporations, and rains, which is changing the dynamics of your ocean. So as water is going up out of it, that's changing the temperature, the salt, the alkalinity of it. That's having an impact. And then you can see where the rains would be cooling areas. So the rains and evaporations are an important part of our ocean currents and our weather. So due to our Earth's rotation, our atmospheric circulation patterns tend to go from east to west and north to south. So that's creating our winds. Westerly winds tend to be large scale systems moving heat to the poles. So that issue of trying to get that heat up to those poles can create some nasty weather events that we may experience. So it's all weather related. So then we do have other things that impacts weather. We have, the land and ocean temperature differences. We know that by the La Nina, that's the ocean temperatures impacting our weather. We have mountain ranges, ice sheets, and vegetation that also impacts and creates that are associated with currents. Changing in these factors that impact weather can have large, well, let's go back. That's supposed to be continents.
Okay.
And, so North American continents could have somewhat its own weather. Even back at the time of the Little Ice Age, North America tends to have warmer summers and cooler winters than Europe. So when the European settlers came here, that was a new thing to them to have colder winters than that they were accustomed to. And that's because of the climate that's associated with our continent, because we have the Rocky Mountains, the Appalachian Mountains, We have the ice cap that's up in Canada that's impacting our weather. And then we have our own type of vegetation. We have that huge prairie system in the United States and the eastern forests. So the vegetation that we had and that all built up, that creates our own climate. So our winters may be cooler because another part of another continent tends to be warmer. That also impacts our weather. So the different continents will tend to have their own weather. So we're not going to be like Europe. Anyone that grows wheat wishes we had the wheat climate that Europe has or England does. They can grow 40, 50 more bushels of wheat just because of their climate that they have for that island. That's different than our climate. So we can do the exact same things, but we won't ever get that because they get yields at almost as high as corn yields in North America and Europe because of their climate. They have a longer growing period for their winter wheat. So if we start changing these factors like temperatures in the oceans, if something happens to vegetation, which we've disforested our world, right? We did it early and we brought ours back some. But as we brought ours back, our competition in South America gets two bulldozers with a log change and they just go across and take out all the vegetation to add more acres to grow crops on. So it's not so much the rainforest, but we're removing long-term vegetation that's been present, that's more shrubs and small trees to add to farmland down there. Asia has deforested in the last couple of centuries quite a bit because of needs and population growth. So as we deforest areas and change the vegetation, that can have an impact on our global circulation of atmosphere and ocean currents and weather. So what we do does change weather. So climate change, wow. So first of all, we have things like natural features that can change our climate. In fact, that's one theory for the mini ice age. There was a lot more volcanic activity during that period, putting out that particulate matter that's going to reflect more of the solar radiation and can have an impact on global temperatures. Because during that period, we were in a trend of getting cooler, during that period. So then we have atmospheric ice interactions, ocean coupling. So evaporation, we have many things. So what we're doing, and of course, our industrial revolution may have been what stopped the mini ice age. Was that period when it stopped getting cooler. So we may have already changed our climate, possibly in a positive way, because that mini ice age was starting to wipe out parts of Switzerland as the glaciers were coming down, taking out villages and farms. So they were having some issues back then. I'm still thinking. I'm looking at the time. Maybe I need to go to the next slide. But, so there's a lot going on. And so we have the aerosols too, that up in the air that can change as well. So I guess my thought here is it's hard to say for sure what is changing our climate now. We have a good idea based upon an event that's happening, but there's no model that we can put together that can take in all this chaos accurately. Would you agree with that statement?
Yeah, in spite of the fact that you said we've got 9 different systems where we use to predict or give us an idea what weather patterns are.
And we have models on climate change too, multiple ones. And some we want to just get rid of because they say it's too late to even change it. So we don't want those. So we have a lot of, so we're trying to in those models, take in this diversity of things that are happening to look forward. And we're using models to try and to deal with just short-term weather forecasts. We have challenges there, but we'll talk about, the greenhouse gases here towards the end. Okay. So I want to say that, yeah, there was a major change in weather, and we really don't know what caused this. But you can see in the middle ice age, these are the global average temperature change. And it happened more in the northern hemisphere than the southern hemisphere. It did change the weather like in Australia, but not as extremely movement to cold as up here in the northern hemisphere. But you can see from about it's actually 1200. You can see it's starting to trend downwards. And then the major events occurred in this time frame when we got to those real significant cold changes that were impacting our climate.
Can you get this information from core samples of the ice? Is that how they?
There's been a lot of research on there. They documented with carbon dating when plant was killed. And that was actually earlier than this period due to a major change in the weather environment. So the glacial were starting to come down off the polar ice caps, and that's reflecting more of your solar radiation. So you can see how that could be impacting your global temperature as that event started moving over time. And they were able to document the movement of glacier material by finding plants they carbon dated that were killed by it.
It's pretty amazing how they got to get that information.
Yeah, and we don't want to look at this far end. I mean, what's happening now with global average temperature? Now, let's look at the scale before I scare you. Look at the scale. Don't look at the graph, look at the scale. Because we can prove anything if we just adjust our scale small enough to look like a major change. But we were going down about 0.02 degrees Celsius over that period of time on an annual basis. So there was starting to shift towards a colder global temperature, and then we bounced back up to where now. They're saying, according to this graph, we're +1 compared to where we were. So, we got down to 0 Celsius change in average global temperature just a little bit before we went back up. But that little bit had a dramatic impact in the northern hemisphere.
So am I understand it correctly that up until approximately 1300, we were around 0 to +0.3 in that whole period of time for
Now this is
1300 years. We're around 0 to 0.4.
yeah, as far as variability and global temperature.
And so from that, am I also understanding that a drop from that average or average around 0.2 in the positive to around 0.2 in the negative? So a drop of an average of 0.4 degrees Celsius produced a little ice age.
Yeah.
And so am I also understanding that we've had a change from that period of time to, and it never varied for 1300 years, it never really varied more than 0.4 degrees Celsius. And so we went from a little ice age and then maybe -0.2 up to very recently, or you don't take it all the way to 2000, but so in the 1900s, in the 1900s, it doesn't go all the way to today.
Well, that's our
But in 1900, it went up to +1.2 2 approximately.
That's what that graph is showing, a change in average global temperature, and we're trying to keep it below 2. I mean, that's the stated world goal, is to keep it below 2.
So that would probably mean brought about by the Industrial Revolution during that period.
Well, that's kind of what my point is. They're thinking the Industrial Revolution, maybe it stopped in little ice age.
Yeah, because they heat, you have coal, everything was burning coal back then, you
Yeah.
know, manufacturing things, sure.
Because remember, we used to be using blubber back here.
Yeah,
You know, the first energy source that lit homes and stuff was well blubber. That's really why they hunted wells. It wasn't for meat, it's for the
Yeah.
blubber,
Well, yeah.
the well oil. So that's our first energy source. And then we found these, we found oil, and then we started figuring out what we can do with oil.
Unfortunately.
And then
it's
we
gonna
were
put a push on
burning.
The accelerator.
Yeah, and then, but Europe was burning peat way back when too, so we've been burning some peat and wood, but the peat, peat would be like burning charcoal. You're taking something that was, stored in the soil. Burning trees, we usually plant more trees, you would hope, but maybe not. Indiana was 85% trees when we settled the state of Indiana. Settler said she wished she could someday see the sun again, because that's how forested Indiana was. She never saw the sunlight. She just was hoping someday she'd get to see the sunlight again. And we went down to less than 15% forested. We're about 15 or a little higher now. So we dramatically changed the vegetation in the state of Indiana in a very short period of time.
But during that little ice age, higher altitudes in Europe, the snowpack actually increased.
Yeah. Like in Switzerland, there's actually a glacier moving into the Switzerland that was just trying to cover landscapes permanently. So you can't use it anymore to grow crops. And let's go to the next slide to kind of document some of the things that happened. So in 1250, the Atlantic pack ice began to grow. They were able to determine finding that vegetation and stuff to document that. In 1275 to 1300, the radiocarbon did date plants killed by the glacier, glaciation. So it moved into new areas, changed the environment to where it killed vegetation. 1300, when they couldn't count on having a warm summer anymore. Can you imagine that? We don't like real hot summers, but never having a warm summer again. You just couldn't count on that happening to have a good growing season. 1350, there's a great famine that occurred, 1350 to 1370, due to a drought that was brought on, and they didn't get the seasonal rains that they normally did. So the weather changed to the point where they had a major drought that people lost lives. So we had a worldwide glacier expansion in 1560 to 1630. So they had a new minimum occurred climate-wise in 1650, so it was a major change. By the way, this is why Germans drink beer and not wine, because the climate changed too much they couldn't grow grapes anymore. So being a German heritage, that's why I like my beer.
They wanted cold beer. They don't have that now. What happened?
And then the latter half of the 19th century is when the little ice age ended, and that's when the Industrial Revolution was occurring. That was post-Civil War when this actually ended, and we had a lot of factories in North America and Europe. That's where you made money if you, the steel industry that started up, you put you were wanting to be close to the front gates of the steel industry because usually someone died every day. So if you're an undertaker, you wanted that business. Because imagine this, back then they worked 12-hour shifts. How many days of the year? Every day of the year. They never got a day off, 12-hour shifts.
Good thing unions came along.
Well, there's a reason why unions can't strike. We were,
That's one of them.
I'm not gonna talk about slavery, but how we utilize people in northern part of our United States and the industry wasn't, well, that wasn't very nice either. So this is just a documenting a painting that the frozen times in England. That was 1677. You can see it was iced over solid. There was mention of one attack that an iced over area that was new. They just crossed the ice to attack another country that, you know, previously you'd have to have boats to get to, and now you'd have to get boats too, but they could just march across the ice. So it was a major change. So yeah, I already mentioned Switzerland in the mid 1700th century, 1650 or so, that the glaciers were, that expansion was actually taking out farmlands and villages. You know, they had actually a frost there from 1608 until 1840. Then it started warming up again, and they didn't have that consistent freezing of the river. Iceland one year, the harbors were frozen in for miles out, and that had a huge impact on that island. The Baltic Sea was frozen a couple of times due to this change in temperature. 1607, 1608 here in the United States and Maine, there's a huge population loss due to the severe winter that winter. They were not prepared for those winters. New York Harbor was totally frozen in 1780, so you could just walk from the islands. You didn't need boats to go from the different islands to New York City area. And in the early 19th century, there was Indiana settler documented ice in July in the creek. So you can imagine how hard that was to have consistent crop production and stuff, where we could have a freeze event in July. Now, I had one in June in southern Indiana when I was down there, so it happened in modern times too. It's just weird weather. But in July, actually seeing ice, that's pretty scary. So that little ice age cost lives, changed societies. Part of the witch trials was because they were blaming people for the bad weather. That actually was part of the culture. It started in Europe where they had witch trials. So sorry, Christine, I blame you. You're a witch, so we're going to take you to trial. Can you imagine?
It works.
But it was you know, a dramatic event that lasted centuries back then that impacted our global climate. So they really don't know what caused it. You know, looking back, they don't know. The solar activity was a little bit weird. Again, they document that through ice and studying the ice of all things and carbon dating. But it was a little odd. You could have a shift in the Earth's orbit. Why is the Sahara Desert a desert? They say about 1600 before BC, before Christ, the Earth axis, they think, changed enough that it changed the weather pattern over the Sahara Desert where they stopped getting rain. They still have a huge aquifer underneath that desert from when they did have good recharge. But it became a desert because it stopped getting its seasonal rains. So something, you know, so the globe could have an impact on it. I already mentioned that. But some even predict the changes in human population of all things Native Americans. They're saying we stopped Native Americans' productivity by giving them disease and them dying off, that population change impacted it here. And then increased populations elsewhere could have impacted it. So different population shifts, they think, could have had the impact to cause the change in the Earth's global temperature. So what's happening recently? So I know these are small maps, but what they're comparing back to is the U.S. annual temperature compared to 20th century averages. So our past century average is what we're comparing back to. And you can see that as we get to our most recent climate predictions of norms, our temperatures are warmer. So again, look at the scale, it's -1 degree to +1 degree. So you can see here in Indiana, we were warmer than compared to the past century. So when they say we're gonna have normal temperatures now on this new climate change model that NOAA put together, our temperatures, our normal temperatures are actually different than they used to be. We just introduced that 2021 this year. So when they say normals now, it's not a lot warmer at the normal temperature, but it is a little warm. So I can compare back. Let's go through. See, this was not much different back here. 1961, 60, I remember. 78, 79, 80, 81, 82. In that time frame, it was cold in the winter time. I remember that. Remember, we used to have snow from November to April. You know, that's why everyone had snowmobiles back then. So our climate was, for that period, cooler than we know it is now. But you can just, and then look at what's happened out west. They already have that Arizona temperature is even a little bit warmer now. And that consistent warming is not good for how they get water to LA because they're depending on that snow on the mountains. Oh, I gotta move. Okay, go on. Christina's got something to share. And the U.S. annual precipitation compared to the 20th century. Can you see the shift here too? That we're a little drier out west and we're wetter here. So like you're saying, the Midwest, we're a little warmer, but that means my strawberries now make it through the winter instead of last 2 winters, I have not covered my strawberries and they made it through the winter. They usually winter kill. And we get more moisture. So we have that advantage as well. Okay. And this is just looking at a winter mean temperature change. So it's not a big change, but we're warmer in the winter. We can see that. Okay. And then winter precipitation, not a lot of change, but some areas it's a good thing. You get more moisture in the winter, so that's a positive for those regions. So like in South Dakota, North Dakota, hopefully that plays out to where they get more moisture. But then we see the opposite effect in some of our drier areas. They're getting less moisture.
Bob, do you think some of these changes will move crops? Do you think farmers will give up if climate stays this way?
Well, the real issue is, where the Rocky Mountains is, we need that moisture and we don't want warmer temperatures there because we want that polar, the mountain caps to have all that stored water to fill the reservoirs in California in those drier regions that don't have enough annual rainfall to supply their water needs. So city of LA is actually looking at recycling all their water, so that sewer water is going to come back as drinking water, because they're not getting enough water to meet their city needs. So they're looking at doing, which must be cheaper than taking the salt out of seawater, I assume, what they're planning to do. So yes, not yet, but if the changes continue, yes, that could impact, because of North Dakota, because actually the drought is a 20-year drought out here, longer than the Dust Bowl drought. So we got to get out of that drought out west. There's crops in California that are not being raised, and there's probably almond trees that are dying because they need so much water. And they're not going to give the water to crop production in California if they need it for the people.
The marijuana growers are taking from the almond growers.
That's right. That's right.
They're diverting the water. At least they used to be before it was legalized. Yeah, they were stealing water from the farmers.
The worst thing that happened to marijuana profitability is making it legal. The first auction of a marijuana grower, he said he got $2 million, but that was $8 million less when he sold it illegally.
Oh yeah, well, actually, sure.
Okay, let me finish up. So what's causing this? It's what we're seeing is the metric ton of carbon emissions from fossil fuels since 1900 to 2014. Our population continues to grow on this globe. It's been a huge change from 1900 to 2000. We've added billions of people to the world population, and they need heat and services. Even in countries we don't think they'll use as much, they still need it. Okay, so that's been the major change. And so the makeup of greenhouse gas release, we're releasing about 80% carbon dioxide, 10% methane, nitrous oxide again 7, and fluorinated gases 3%. Okay, we already covered that. And where is it coming from? This is new. This is new. The biggest category now is transportation, 29%. That can be why President Biden's pushing for electronic cars, because the energy industry has been using renewable energy enough, but the wind turbines and solar panels, it's dropping. It's used to be higher in 29% release of greenhouse gases. It's now down to 25%. 23% is industry. In California, they get so many carbon credits for their industry, then they have to buy credits, meaning they have to pay someone to grow trees to offset their use. Agriculture is 10%, and I'll visit that again. Commercial 7% and 6%, is residential. Okay. Globally, China is the major contributor. 30% is coming from China. We are too, 15% from the United States, roughly. EU is 14%. India is right around 5%. Actually, that bar should be a little higher, 6%. Russia is like 5%. My bars didn't come out good when I went to that. And Japan's 4%. I know that's 4 or 5, and that's closer to 7 or 8. So you can see which countries are the major contributors. It's the industrial nations. And that makes sense, doesn't it? A lot's happening in India and Europe. And then the rest of the world is only 30%, so they're tied with China. But we have to remember there's a carbon cycle, so though we're releasing carbon dioxide at a much larger level using our fossil fuels into the atmosphere, we got to realize that some things happening in the system are not really that big of a change. Agriculture, as we release greenhouse gases, we plant a crop that's going to take it back in. The cattle industry, as long as we don't change the number of cattle, we're growing crops that take it back in. So there's a carbon cycle there. So, and they say, the cattle people are upset when they see that agriculture, a cow, and 10% because they're only 3% as an industry. And our cows are more efficiently managed. And that methane breaks down quicker than what they attribute it to. So in 9 to 12 years, that's carbon dioxide, not methane up there. And then that carbon dioxide is taken back up by what we're growing to feed our cattle industry. And then we have, we could be a solution in agriculture by using methane digesters that actually produce energy from that methane versus it going up into the air. And there's a researcher at UC Davis actually trying to address this for agriculture. He has all his cattle in like a tent where he captures all the greenhouse gases, and then he does research monitoring what feeds increased greenhouse gas release. So if we have a more efficient diet where it's not fermented as long, it won't, greenhouse gas production goes down. So agriculture, we're a part of a carbon cycle. The ocean is a major part of the carbon cycle. My concern is this: we're releasing carbon dioxide and it's not part of a carbon cycle because we're using those fossil fuels and releasing them without having that being part of a carbon cycle. So that's what I was talking about in Europe. They're trying to address that. Any questions? So this is really complex because we can actually, if we create more carbon sinks, we can help ourselves out. But the real thing working against us is the world population.